Good morning, students. In this session, we are going to discuss about transmission impairments. The last class we discussed about the digital analog and digital data, analog and digital signal. In this class, we'll move to the transmission impairment topic. What is transmission impairments? In the network, we can send and receive the message through the transmission medium. So the sender can sending the data, the receiver can receive the data. In between sender and receiver, the transmission medium is there. The transmission medium may be twisted pair, coaxial cable or fiber optic, etc. So when you send the sender sending the data at that time, the signals travel through transmission media which are not perfect because some noise will be added. The imperfection causes signal impairment. That means the signal at the beginning of the medium is not the same as the signal at the end of the medium. So what is transmission impairments means? There is a changes in function or structure of the signal. You consider the example signal. Here there are 2 points, point 1, point 2. Point 1 sender side, point 2 receiver side. So the point 1, that's a transmitter. We can transmit the signal like this at the point 1, transmitter signal. So when you transmit the signal through the transmission medium, the noise will be added. So the signals, the structure of the signal is changed. So in the point 2, the receiver receive the signal that is different from the transmitted signal. So the received signal is different when you compare with the transmitted signal. So the signal at the beginning of the medium is not the same as the signal at the end of the medium. So that is a transmission impairment. There are 3 types of transmission impairments. One is attenuation, distortion and noise. So these are the 3 different types of transmission impairments. First one, attenuation. So what is attenuation means? The attenuation refers to loss of energy by a signal time. So when you send the signal through the transmission medium, some energy will be lost. So when we compare the transmitter, the input signal with the output signal, the energy is lost. So the attenuation is to compare the 2 signals whether the energy is lost or not. So the attenuation talking about the loss of energy. When a signal, that is a symbol signal or composite signal, that maybe travels through the transmission medium, it loses some of its energy. To overcome this loss of energy, we can use the amplifier. Okay, so the amplifier is used to amplify the signal. So through the transmission medium, when you send the signal, the input signal is changed. The structure of the input signal is changed because of some of the energy is lost. So to compensate this energy loss, we can use the amplifier. The amplifiers are used to compensate the loss of energy by amplifying the signal. Normally, the attenuation is measured as decibel. We can specify the decibel, that is dB. So that dB equal to 10 log P2 by P1, the base 10. P1 equal to input signal, P2 equal to output signal. We'll consider the two examples for the attenuation. So loss of energy. The first example, suppose a signal travels through a transmission medium and its power is reduced to 1 off. So here we consider the two powers P1 and P2. The second power is reduced to 1 off. This means that P2 is off P1. Now we have to find out the attenuation, the loss of power. So the loss of power can be calculated as 10 log P2 divided by P1, the base 10. So that is equal to 10 log 1 by 2, that means 0.5. So P2 equal to 0.5 P1. So we can write 10 log 0.5 P1 divided by P1. That's equal to 10 log 0.5, that's equal to 10 into minus 0.3, that is equal to minus 3 decibel. Minus 3 decibel, that is a 3 decibel. So a loss of 3 decibel is equivalent to losing 1 of the power. So this is the first example. Then when you consider the next example, example 2, a signal travels through an amplifier and its power is increased 10 times. So increased 10 times means P2 equal to 10 P1. In the first example, the power is reduced to 1 off. So P2 equal to off P1. We can apply the value P2 equal to off P1, that is equal to 0.5 P1. But in the example 2, the power is increased 10 times. So P2 equal to 10 P1. Now the amplification can be calculated as, the formula is 10 log P2 by P1, 10. The base is 10. That is equal to 10 log 10 P1 divided by P1, the base 10. So that is equal to 10 log 10, the base to the base 10, that is equal to 10 log 10 to the base 10, that is equal to 1. So 10 into 1, 10 decibel. So to find the loss of energy, we can use the formula 10 log P2 divided by P1 to the base 10. Okay, P1 is input signal, P2 is output signal. So these are the two examples for attenuation. Then next transmission impairment, distortion. In the distortion, the shape of the signal is changed. That means signal change its form or shape. In the attenuation, the energy is lost, but distortion, the shape of the signal be changed. The distortion occur in composite signal. Each frequency component has its own propagation speed traveling through a medium. The different components therefore arrive with different delay at the receiver. This means that the signals have different phases at the receiver than they did at the source. You consider this example for the distortion at the center side, at the receiver side. At the center side, the input signal is composite signal sent the signal is like this. Then this composite signal is made up of these three components. Components in phase, three components. Here, each signal component has its own propagation speed through the medium. Therefore, it is own delay in arriving at the final destination. So, at the receiver side, the composite signal received, the structure of the signal may be changed. So, different delay. The different components arrive with different delay at the receiver. So, the structure of the signal is changed in the distortion. Then noise. So, there are different types of noise: thermal noise, induced noise, crosstalk noise, impulse noise. Thermal noise, that's a random noise of electrons in the wire, creates an extra signal. Induced noise from motors or appliances. Devices act as transmitter antenna and medium as receiving antenna. The crosstalk noise, same as above, but between two wires. Then impulse noise, spikes that result from power lines or lightning, etc. Okay, these are the noise. So when you send the signal from the center side, some noise will be added. So when you send through the transmission medium, at that time some noise will be added with the input signal. So the output signal may be changed. There is a imperfection. So noise will be added. So this is the example. Point 1, point 2, point 1 sender side, point 2 receiver side. Between the sender and receiver, there is a transmission medium. So while sending the input signal through the transmission medium, some noise will be added. So the signal is changed during the transmission medium. So the noise will be added. So at the receiver side, the input signal is changed. It's a different signal. It's not same as your input signal. The output signal is different when you compare with the input signal, transmitter signal. Okay, at the point 2, the received signal. Point 1, transmitter signal. So when you compare these two signal, point 1 signal and point 2 signal, transmitter signal and received signal, these two signals may change. Why? Because when you send the signal through the transmission medium, some noise will be added. So the transmitter, when you compare the transmitter signal with the received signal, they may be different. They are different. Signal to noise ratio. To measure the quality of the system in the SNR is often used. The SNR equal to, that's a signal to noise ratio, average signal power divided by average noise power. SNR is a ratio between two powers. It is usually given in decibel and referred to as SNR dB. Then, so now we discussed about these three transmission impairments. What are they? Attenuation, distortion and noise. In the attenuation, there is a loss of energy. Distortion, the structure of the or shape of the signal changed. The noise will be added with the signal. So the output signal is different when you compare with the input signal. So that is the transmission impairment. What is the difference between attenuation and distortion? The difference between attenuation and distortion lies is the fact that in attenuation that the signal loses some part of energy where the amplitude of the signal may decreases. On the other hand, distortion is the change in the waveform of the signal due to noise. Thank you, students.